four graphs which you need to familiarize yourself with. There is the graph of activity. This side it will be activity. I won't write to avoid wasting time. Okay, so on the y-axis we have activity, so we can have enzyme concentration here. Okay, so what happens, imagine this scenario where you have two enzymes, okay, three enzymes, then okay, let me just put two enzymes, then we have three substrates. Okay, so what happens is this enzyme will be acting on this substrate. Well, this enzyme is acting on this substrate. Okay, this one will be waiting. Okay, so what happens if we increase the amount of enzymes? Okay, we increase enzyme concentration, we add another enzyme. Okay, then this enzyme will be acting on this enzyme. So all these three enzymes will be working at the same time. Therefore, the reaction is going to be very fast because all the substrate is being worked on. Okay, that's the first scenario. Now imagine a situation where we add another enzyme. Okay, we add another enzyme. What is this enzyme going to be doing? Nothing. So even if you increase the number of enzymes, there are no substrates to work on. Therefore, the activity still won't increase despite increasing the enzyme concentration. So the graph for this is like this. Okay, as you are increasing the number, the concentration of enzyme, the activity will be increasing. A point is going to be reached where even if you increase the these people anyway, so as you're increasing the number of enzymes, the activity will increase. Then a point is going to be reached where even if you increase the number of enzymes, as you can see going to the right, it means the concentration of the enzyme is increasing. There will be no a corresponding increase in the amount of substrate. That's why the graph is like this. Okay, it shows that even if you are increasing the number of enzymes, for example, here, if I say this is a new increment in the enzyme concentration, the activity might be here, so which means they are going to meet somewhere here. That's why the graph is like this. If I pick another point just like that, but when that point is reached, when all the substrates have been used, for example, you can say, okay, let's increase the number of enzymes to here, but the activity won't increase to here. It will still be at the same level. Okay, that's why the graph levels off. Hope you have understood. You have gotten that one. Then the other one is enzyme against the substrate. Okay, enzyme against substrate. I mean enzyme activity against substrate. So the behavior is the same. Okay, so we can picture it like this. Okay, let me just remove these things here so that I'm able to illustrate well. Okay, yeah, so you can picture it like this. So here we have enzyme. Okay, so let's say we have, like I had indicated, enzyme and substrate. Okay, so if for example there's another enzyme here, okay, there's another enzyme here. So if you increase the number of substrate, this enzyme will become busy, like I explained. But what if you increase another substrate? There will be no enzyme to work on this substrate. So even if you keep on increasing the number of substrates, the activity will still remain at the same position. So even for substrate, it will just be the same as the one for enzyme, which means like this. Okay, then after that there's the one for temperature. So temperature, when the temperature is low, the enzyme activity is low. As you're increasing the temperature, the enzyme activity will be increasing. Okay, when the optimum temperature is reached, okay, the optimum temperature is reached, the activity will be at its optimum, like it will be at its highest. But beyond the optimum, the activity falls off because the enzyme gets denatured. For pH, the enzyme will be, the activity is going to be low at any other pH apart from the optimum pH. So if for this specific enzyme, the pH is 7, then the activity will be like this. Okay, so it will just be highest at the optimum pH. At any other pH, it's low. So these are the four graphs for enzymes.